This is the Rame Hart contact angle goniometer. This goniometer has drop image software and a controlling computer. Easy to use contact angle design to offer the highest level of precision computer aided contact angle analysis. The contact angle range is between 0 to 180 degrees with a resolution of 0.1 degree and an accuracy of plus and minus 0.1 degrees. It is powered by 120 volts AC, 60 hertz. Now let me first show you a couple of important things. Very important is to be completely level. You'll notice that on the carriage here, there in the back here, there is a bubble level that's here. And after leveling the measurement bench, you should also level the chuck as well, or the platform. Very important. Now we're going to show you how to start everything up. First we'll turn on the monitor. Then we'll turn on the computer, which we'll get to in just a moment. And we'll turn on the light source to the fiber optic bundle. We'll wait for the software to load. Okay, this is our main screen. First, I'd like to show you the connections around the back. This is state-of-the-art. This is the entire computer right here that controls the entire system. And what I've done is I've made a little chart here, which I will tape to the top, that shows you where the actual connections are. The camera, the keyboard, the mouse, the monitor, and of course the power. That's all that's connected to this unit to make the system work. In turn, there's power for the illumination power supply, and for the monitor, and of course for the computer itself. If we return to the front, I'd like to show you a few things. First, we will start up the software. Okay. Take the cover off the lens, and as you can see, we are live now. I thought the first thing that I'd show you is there is a special calibration tool here that has a round sphere and a horizontal pin as well. This is used to calibrate the instrument, and in the manual there are very clear instructions on how to set up the calibration of this piece of equipment. Also in the manual there is the program instructions itself, and what's very convenient in addition to the manual is that online on YouTube they have a series of tutorials that take you every step of the way of using this instrument. It will simulate exactly what you see on your main screen here and show you how to use the different options for surface tension, surface energy measurements, and it's very, very convenient. Now, I think I'll start off by just showing you the basics. Now in the basics, we have drop angle tool. We're going to drop that down here. We're going to put that over here. Now, there are different options here, so you can do different types of measurements, but we're going to use the standard measurement for purposes of our demonstration. Now, if you look at the screen here, what we're going to do is we're going to raise the pedestal up just enough, and we're just going to, each time, we're going to try to put the same volume of water drops down for our demonstration. There, start with this one. We will move it into place with our Y adjustment. We will then use this dial here. This is your focus right here. It is a mechanical focus, and you just look for your crossover point right about there, and then we will move it down till we get our baseline set. There. Now what we'll do is we'll take a measurement, and we have that measurement. Now what we can do is a little experiment here, is that is on a surface of aluminum. We're going to lower that down out of the way. We're going to use a piece of coated aluminum. This surface here is raw aluminum. This has a plastic coating on it. Let's see if that makes a difference. We will raise our pedestal back up, and we'll put us a drop down. There we go. We'll get that centered respectively. We'll focus. And let's lower that down. We will then start. We're just about on there too. Hold on. Let me just get that baseline a little bit better set up. Hold on, folks. Almost there. There we go. And we can take our measurement. All right, that's more like it. The first one was off. I've seen most water drops on an aluminum surface are anywhere between 58 to 68 degrees, respectively, almost on both sides. So we'll take that measurement again to make sure. And let's say you wanted to take measurements while the particular liquid, like water, was dissolving, not dissolving, but was actually getting smaller. What you could do is you could go up to options here. Hold on. And you could put in, let's say, 5 consecutive measurements. So that when we restart, we could put 5 measurements. And what's interesting about that, hold on, I'm going to clear these measurements out. Okay. And I'm going to take those 5 measurements again. And then blow on that spot a little bit. And let's take another measurement. Ooh! As you can see, we've made it a little bit smaller. So you can plot all of these respectively as a function of time as well. So what I think we'll do now is we'll take another piece of material. Since we're just using water, we cannot change the different liquids for purposes of this demonstration, but we can change the surface that they're on. So now we're going to take a piece of regular cold rolled steel, which is probably very much like the aluminum. And what we will do is we will start our run here. Let's say we clear all of our data out, and we'll start it again. And at our drop, got a big one there this time. Now that's on a piece of steel. Let's set our baseline up. There. And we'll take a measurement. Aha. About 72 degrees on one side, 73 on another, with a mean of 73.2. That's pretty good. Now we're going to do the same thing again, just for fun. And this time we'll put it on a piece of galvanized steel. Now galvanized steel obviously is a coated metal. The surface is not completely smooth, so let's see how it does on that. We'll just turn our scan on for a minute, turn it back on. There. Let me refocus. And we'll lower, or rather raise up to our baseline. And we'll take our actual measurement and compare the two steels, which you can see is virtually the same. That's pretty interesting. Let's clear all this out again. And this time, we're going to go to Teflon. Now, this is not the best piece of Teflon, but it'll serve our purpose. Lower. A little bit tiny drop there. And we'll start. And we will lower and center respectively. Refocus. Let's take our measurement. Wow, what a difference. It's a very small drop, so it's pushing the data together. That's nothing wrong with the software. As a matter of fact, on Teflon, look at how much different the angle is. That's because the surface of Teflon is not as wettable as the surfaces of metal or other porous materials. But we'll leave that right there. Another big drop to it. Now let's see what we got. Oh boy. This, because Teflon is slippery, the drop can move from side to side. So as you see from this measurement here, we have quite a difference because the drop is leaning to one side. We have 85 on one side and 93 on the other. These are very good comparisons here. Now, finally, this is a fun one. This, of course, is just a piece of pine, a piece of wood, which is very porous and, of course, will soak up water almost immediately as compared to the other hard surfaces we were using in our demonstration. So, just for fun, we'll put that on there. And now you got to look quick with this one, because this is pretty cool how this works. And if I can get it on the baseline, let me see what I can do here. Hold on. You will see it not dissolve, but actually migrate into the wood surface. It isn't dissolving. It actually is working its way down into the porous little grooves of the metal of the wood surface. So let's start again, and this will be fun. You'll like this. Too big a drop. So we can't really use that one, but we'll do it one more time just to show you how cool this is. See if I can pull off just a tiny drop. And you'll see, as it wets into the surface, you will see the angles change. Oh, no good. You know what? We'll bring this up a little bit closer. See if we can get that drop on there. There we go. Wow. But we couldn't get down to the baseline in time. As you can see, it's trying. Let me see if I can do it from there. Hold on. I'm gonna catch it in the air. As you can see, it wets immediately, so that isn't a very good representation. But boom. So it flattens out. Now, if something is totally wettable, that means you will have zero angle. That means that the liquid has the ability to totally flatten out on the surface it's being tested in. One other nice feature about this is you can save these images. For example, let's say I did one here on the aluminum surface, like when we started. Oops. Hold on, let me try that again. Ah, that's a nice one. Wow. Hold on, let's fix that baseline here. Get something more realistic. There we are, back to our 58. That's what I see a lot with water. Now, if you wanted to save this, you could click into here. First, we'll save its profile. And we'll call it, let's say, test 1. And we'll save that profile. And you can also save the picture as well. And we'll call this test 2. Save. Now you can also take a picture of this and keep it this is live, as you know, but you can also take a picture of it, and even though it's still measuring, it's still there. Here we can recall, we can open our picture that we took just before, and there's the picture that we took before, and we can open our profile that we took before. And that gives you the profile as well. One of the other things you can do with this is you can also zoom in on the picture. Let's say you have a very small drop. This is at 100%. You can go 125. Or you can go all the way up and make it really large. So it actually increases the size of the screen itself, so you can see better, you can be more accurate when setting your baseline. And last but not least, hold on. We'll return this back to our normal size of 100%. Is we can do a little thing here where we have an intensity histogram. And what that actually shows you is the intensity of the light. Now, that's done by moving this line around. You see the crosshairs? Now, let's move this little block over here. Right now, the crosshairs are in total white. So we have, again, this is a grayscale, so we have 256 levels of gray. So if we lower those crosshairs, see we're still in the light, we can then see our intensity. So we can actually go around here, and the intensity is pretty much the same, and then we have a little bit of a reflection there. So that's pretty cool as well. And again, once you turn this off, and it's presently configured this way, and you start it up again, it will come back into live. So it's pretty easy to use. Again, I suggest you definitely use the tutorials. They're very, very helpful, and there's a number of them online from the manufacturer. And this completes this demonstration.